Welcome to solverfy.
The following data for question 2, parts A and B. So for part A, we're given that our independent data, or what they're calling our x-axis variable, starts from 1, goes to 2 to 3, it ranges by 1 all the way up to 8. So we can input that data here. I'm going to call this our x and our y. Actually, they call it t, right? And they call this x, and the unit is feet. Okay, and then the data they gave us is 2.3, 8.3, 11.8, 15.7, 20.8, 25.3, 34.2, and 37.2. And we've been asked to report on the slope, intercept, and reliability of the slope of intercept for a linear fit for this data. That was 37.2. Okay, and we can get all of this information using the linist function, or linear estimate. And the way that we have to do this is select a 2-column by 5-row set of cells, go into the formula editor, and do equals linest. Okay, we give it the y values, so I'll highlight the second column. Then we give it the x values, so I'll highlight the first column. Then we say true. This just tells us that we're not forcing the intercept to be 0. And then true again tells us to give us all the useful statistical information. Okay, and from here, instead of hitting enter like you normally would when you're doing an array formula like this, you need to hit Control, Shift, and enter. And then what we get out is the following. And the meaning of all of these is the slope is given here, the standard error for the slope is given here, and the r squared is given here. There's something called the f value that's given here, and the SS regression. We're not going to need the f for the SS regression. We get the intercept here. Intercept, we get the standard error for the intercept. We get the residual standard error, and we get our degrees of freedom and our SS residual. Again, all we're going to really need is the slope, the intercept. Great. Okay, so now what we need to do is report the actual line that we got. Okay. And they want us to make sure that we do this in with our units, right? So the way we have it is our dependent variable is x, right? So x depends on t, right? So that means x, let me make this text larger, in feet is equal to, and then we give it the equation of our line, which is 4.992, well, let's say 4.993, to have one more digit, is the slope, and the units for this need to give feet when multiplied by t, right? So this has to be feet per second, and then multiplied by t, which is in seconds, right? And that'll give us a final unit of feet. Okay, and then our intercept should just have the same units as x does. So our intercept is negative 3.018 if we round it, and the units of that are just feet. Okay. In terms of reliability, we can report the r squared, right, which we said is 0.988, and the standard error for the slope is 0.224. The standard error for the intercept is 1.134. All right, and then we've been given a second set of data with which to do this. What's nice is that since these are the same column lengths, right, then we can actually just input our data over this data and say this is now 0.1, 0.1, 0.2, 0.3, right? Once we establish the pattern, we can highlight the pattern and drag it down to fill it in. And then we change our x's, 3.7, 7.7, 8.5, 12.1, 13.5, 15.5, 15.3, 15.0. Oh, it looks like there was one additional row of data, so we'll have to alter that slightly, and this becomes 18.7. And now everything in here needs to be stretched slightly. We'll pull that down to cover our new data. We'll pull that down to cover our new data. Remember, we're doing Control-Shift-Enter. Okay, and so here is the data for our line in units, or for our second set of data. Okay, so if we want to report that data, again, in units that match the given data, then we will transcribe the line just as we did before, the equation for the line. Recalling now that our dependent variable is k, which is in joules, is equal to, and then they're giving us the equation of the line, 16.48 is our slope, and this needs to give joules when multiplied by seconds, so it should be joules per second. Right, and then multiplied by our independent variable t, which has units of seconds, and the intercept is 3.98, like so, and that will just have units of joules because it needs to match our k in joules. And again, we can report the r squared standard error for reliability. This has a lower r squared, 0.913. That's actually particularly low, so not so great. And then the standard error for our slope is 1.92, and the standard error for our intercept here is 1.08. Yeah, I guess, if we wanted, we should probably put the units on the slopes, right? The slope should have the same unit as, the standard error for the slope should have the same unit as the slope itself. The standard error for the intercept should also have the same units as the intercept itself. And then the standard error for our slope, again, it's the same units as our actual slope. And the standard error for our intercept is the same units as our intercept. R squareds do not have units, right? They're a unitless value that just tells us how linear and effectively how reliable our data is, or our equation for our line is. So this would be A, and this would be